good morning. Today we are going to learn about the chapter Electromagnetic Induction, and the today's point is the generator. What is mean of generator? We know always we use the generator for produce the electricity. Here generator is a device. Generator is a device which converts mechanical energy into electrical energy. Mechanical energy, that is, we can say that it is obtained from the wind energy, or we can also use the water for mechanical energy, and so on. Here the mechanical energy is converted into electrical energy. To use the generator, here we are going to take, we are generating electrical energy by using the magnetic field or magnetic force. And we have already learned that when a conductor is moving in a magnetic field, it or electric conductor is moving or placed in magnetic field, then a force is applied on that conductor, as well as when a conductor is moving in a magnetic field, then there is a change in magnetic field. As there is a change in magnetic field, the electric current induces in the conductor, or we have already learned about the Faraday's law and Faraday's experiment, and then Lenz's law. That Faraday's experiment, from Faraday's experiment we have learned that the EMF induced in the coil is directly proportional to change in magnetic flux. It means that when we place a coil in a magnetic field, and when this coil is moved from magnetic field away from magnetic field or towards the magnetic field, then EMF induces in the coil and current also produces in the coil. Here this technique are used to generate the electrical energy, to produce the electrical energy. Here to produce the electrical energy we have used two magnetic poles. This is N pole and this is S pole. That is, two hub magnets are used here. Like magnets are used here to produce the strong magnetic field. This is the N pole of magnet and this is the S pole of magnet. This is here the uniform magnetic field will be produced. The direction of magnetic field is from, or magnetic line of forces is from N pole to S pole. Here will be the magnetic field will be produced in between these two poles, and in between these two poles a coil is placed. Here a coil is placed in between these two magnetic poles or in magnetic field, and if we rotate this coil by using the torque, here torque is applied on the axis of this coil. For the torque we can use here turbine to rotate this coil, and the coil will rotate in magnetic field. When this coil rotates in magnetic field, then there is a change in magnetic flux which are passing through the coil, and as there is a change in magnetic flux, then EMF induces in this coil and current produces in the coil, and this current can be observed here by using this bulb. That this bulb will be on when this current passes through this coil. As we stop the rotating of this coil, then this bulb will be off. As we start rotating this coil, the bulb will be on. And that is, from this we can say that the current induces in the coil when the coil rotates in the magnetic field. This coil can be rotated by using the applied torque to produce torque in the coil. We can use here a turbine. And how this coil will rotate and how this EMF will induces in this coil, we will discuss about this. Suppose this is the direction of magnetic field, and when we apply the torque on this coil, the coil will, armature of this coil will move in upward direction. That is, we can say A, B, C, D. The side AB will move in upward direction and side CD will move in downward direction. When torque is applied, side AB will move in upward direction and side CD will move in downward direction. It means that the direction of force is in upward direction. This is the direction of magnetic field. Then the current will induces in this coil as the coil starts to rotate. We can observe this rotation by using this. Suppose this is the coil. This is the coil and these are the armature of this coil. And this coil, here is a N pole and here is a S pole. And this coil will be rotated as this type, and then again this type, and then again this type, and this. One rotation will be complete as this type. Now suppose this is the side AB. This side AB is here. We are connected wires and bulb is used here to observe the electric current, and torque is applied to this coil, and this side will go in upward direction. That is, this is the direction of force, applied force, and this side will move in downward direction due to the torque. Then by using the right hand generator rule, we can find out the direction of EMF induced in the coil and the direction of current. Now we can say that, suppose this is N pole, this is S pole. This symbol indicates that the direction of EMF is inward direction to the plane of paper. Now, by applying the right hand generator rule to find the EMF induced in the coil. How to apply the right hand rule? Stretch the fingers of right hand. Stretch the thumb, forefinger and middle finger of right hand in such way that these fingers are perpendicular to each other, as this type, perpendicular to each other. This thumb is stretched in the direction of force. Then forefinger is stretched in the direction of magnetic field, and then the middle finger will indicate the direction of current or induced current, or we can say the direction of EMF. The direction of EMF and direction of current is same. Therefore, this middle finger will indicate the direction of EMF right hand rule on side AB. Then this forefinger is pointed in the direction of magnetic field. Then the force is outward direction. Therefore, the thumb is stretched in upward direction as like this, and therefore the current, this middle finger will indicate the direction of current. Here the direction of current is shown. We can observe this side is moving in upward direction. Here is a magnetic field, here is a N pole and here is a S pole. Then this coil is rotating as this type. Therefore, we can apply this. This is the direction of magnetic field, and this is the thumb is in the direction of force, and therefore the current is inward direction. That is, this is the inward direction to the plane of paper. Therefore, we can say that this is the direction of current, that is A to B. Then again we can apply. This is the here figure first. Then we can apply here the right hand generator rule on the side CD. How this the current will on this side CD. That is, we can say here this is the direction of magnetic field, direction of force. Force is in downward direction. Therefore, as this type. This is the, and therefore this is the direction of middle finger, that is outward direction to the plane of paper, and therefore the current will be C to D in this direction on this side CD. The EMF and current induced in the coil will be as this type. And here therefore the current will flow as this type, and from B to C. From these two direction of current we can find out the direction of PC, and therefore the current will from A to B, B to C, C to D and D to here, and the bulb will be on, and then here these are the brushes are used here. This is the brush which is attached to this coil. This is also the brush, and here two coils are used to rotate this side, and therefore the current will flow through the bulb in this direction and through this direction to here, and then again in this side. The current will flow in this as this side. Then the second on the side second CD, the direction of current is, we can say this as this side. This indicates that the direction of current is outward side. And when the coil rotating in the magnetic field, this is the direction of current. The coil will rotate as this type, and this side will become as this type, and when this coil is in this position, there will be the change in magnetic flux. The large change in magnetic flux between these two positions, and then again coil will be at this position. That is, the side AB will on this side, here will be the A, B, then C and then D. This side will be on this side. Then what's happened when these two sides, the coils rotate from this side to this side. The half rotation is completed here. then the direction of current will be changes, because the direction of current will be changes. First at all, the direction of current on side CD is in inward direction, but when this coil rotates from this side to this side, then the direction of current on this side AB changes, and therefore the direction of current also changes passing through this coil. Then we can say this is the side A, B, C, D. As in the first case, the conductor is moving upward across the line of force, inducing maximum EMF. Then when the conductor is moving parallel to the magnetic field, that is, when conductor is at this position, this will move in this position, that is the surface area of this coil is parallel to the magnetic field, and therefore in this case we can say that the conductor is moving parallel to the magnetic field, there is no induced EMF, and therefore we can say the second case we can observe here, there is no EMF induced in the coil. Here in first case the maximum EMF will induce in this coil. In second case the no EMF will induce in the coil. E will be equal to 0. Here E is equal to E maximum. And when the third case, when this side is moving in downward direction, this side will become this side and this is moving in downward direction, then the direction of current changes. Direction of current changes, and the direction of current is here outward direction can be shown as this type, and maximum negative EMF will be induces in this coil. The maximum negative EMF will be induces in the coil, because the same conductor moves down across the line of force, and the induced EMF and current is directed opposite to that of the first case. Here EMF induced in the coil is opposite in that of the first case. First at all, the direction of current inside AB is inward, and when this side comes on this side, then the direction of current is out of the plane of paper. Here this is inward direction, and when this side goes to this side, this is the become the outward direction, and therefore at each and every half rotation, when the side changes, then the direction of current also changes. I will again explain this. Suppose सुरुवातीला ही कॉइल या पद्धतीने असेल, ज्यावेळेस ही कॉइल या पद्धतीने रोटेट होते, मॅक्झिमम ईएमएफ इंड्यूस होतो ह्या कॉइल मध्ये, आणि बिकॉज देयर इज अ मॅक्झिमम चेंज इन फ्लक्स d∅dt, मॅक्झिमम चेंज इन ह्या पोझिशनला आणि या पोझिशनला मॅग्नेटिक फ्लक्स मध्ये खूप लार्ज प्रमाणामध्ये चेंज होतो, त्यामुळे ईएमएफ जो इंड्यूस होतो तो पण मॅक्झिमम ईएमएफ इंड्यूस होतो. ज्यावेळेस कॉइल या पोझिशनला येते त्यावेळेस त्याचा जो सरफेस आहे, दिस इज द डायरेक्शन ऑफ सरफेस. डायरेक्शन ऑफ सरफेस अँड डायरेक्शन ऑफ मॅग्नेटिक फील्ड इज सेम. मॅग्नेटिक फील्डचं डायरेक्शन आणि कॉइलच्या सरफेसचं डायरेक्शन सेमच असेल. देअरफॉर द फ्लक्स will be equal to, that is there will be no change in magnetic flux, that is E will be equal to 0. But this is the direction of current at this position, upward direction. When this coil here in this position. Then direction of current again changes. First at all, here the direction of current is in this type, and when this coil rotates as this type, the direction of current become as this type. That is, this is the outward direction and here this is the inward direction. या ठिकाणी डायरेक्शन करंटचं डायरेक्शन कुणीकडे आहे, या डायरेक्शन मध्ये आहे. सपोज दिस इज द इनवर्ड डायरेक्शन. ज्यावेळेस कॉइल रोटेट होऊन या पोझिशनला येते त्यावेळेस बाय द राईट हँड जनरेटर रूल, आता या ठिकाणी मॅग्नेटिक फील्डचं डायरेक्शन तर सेम राहिलेलं आहे, परंतु या ठिकाणी फोर्सचं जे डायरेक्शन आहे ते चेंज झालेलं आहे. त्यामुळे करंटचं डायरेक्शन तुम्हाला या पद्धतीने मिळेल, इकडे मिळेल. म्हणजेच या ठिकाणी ही जी साइड आहे त्यावेळेस साइड चेंज होते, इकडून ही साइड इकडे येते, त्यावेळेस डायरेक्शन जे आहे करंटचं जे डायरेक्शन आहे ते काय होतं, चेंज होतं. म्हणजे प्रत्येक हाफ सायकलला रोटेशनच्या त्या कॉइलच्या रोटेशनच्या प्रत्येक हाफ सायकलला या ठिकाणी जे करंट आहे, जे करंटचं डायरेक्शन आहे ते काय होतं, चेंज होतं या ठिकाणी. म्हणजेच या ठिकाणी पहिल्या केसमध्ये ज्यावेळेस कॉइल इथून अशी रोटेट होत असते या पद्धतीनं, तोपर्यंत सपोज या ठिकाणी बल्ब जो आहे एक सुरुवातीला आपण बल्ब ऑन होणार आहे, त्यावेळेस कॉइल या पोझिशनला येईल साइड ए बी, त्यावेळेस डायरेक्शन करंटचं चेंज होईल आणि करंटचं डायरेक्शन चेंज झाल्यामुळं सपोज सुरुवातीच्या केसमध्ये बल्ब येलो कलरनी लाईट करतो, तर सेकंड केसमध्ये सपोज तो ब्ल्यू कलरने लाईट करत आहे असं आपण कन्सिडर करू. तर प्रत्येक हाफ सायकलला जो बल्ब आहे तो येलो ब्ल्यू येलो ब्ल्यू येलो ब्ल्यू या पद्धतीनं या ठिकाणी लाईटिंग करणार आहे. तर या पद्धतीने या ठिकाणी ह्या जनरेटरचं वर्किंग चालतं. या ठिकाणी युनिफॉर्म मॅग्नेटिक फील्डमध्ये आपण ही कॉइल ठेवलेली आहे आणि या ठिकाणी बारचा यूज करून आपण ही काय कॉइल काय केलेली आहे, रोटेट केलेली आहे. या ठिकाणी आपण कॉइलला हे जे वायर्स आहे हे दिस वायर सीडी इज अटॅच्ड टू दिस ब्रश, या ठिकाणी हा ब्रशचा यूज केलेला आहे. द करंट विल फ्लो थ्रू दिस will be through this coil to this brush and then through bulb and then will be flow through this brush. His coil is touch here to brush and these two circles will also rotate. Therefore there will be no twist in between these two wire. Therefore as the coil rotates and this two coils also rotates to provide the currents in this circuit. This is the direction of current, that is inward direction. First case, when AB is at this position, the direction of current it will be inward direction. It is shown by this symbol. EMF will be maximum, and when the coil, the surface of coil is parallel to the magnetic field, then there will be the EMF will be equal to 0, and where the side AB comes across this side and coil rotates to 180 degree, then the EMF will induces maximum, that is E will be maximum, but the direction of current in first case and direction of current in third case will be opposite. Now we know that the coil is rotating with constant angular velocity. The omega is the angular velocity of the coil, and we know that the theta is equal to omega into t. Theta is the angular displacement of the coil, omega is the angular velocity, and t is the time. And we know that the magnetic flux phi are given by A B cos theta. Magnetic flux are given by AB cos theta. We we have already discussed this equation. Therefore, we can put this value of theta in this equation. Then this will be AB cos omega t. Now, by using the Faraday's law, that is, what is the Faraday's law? The Faraday's law states that EMF induced in the coil is directly proportional to change in magnetic flux. This is d phi by dt. But by the Lenz's law, this E is negative. This E is negative. If there are number of turns in the coil, here are number of turns. This equation is for one turn. If there are two turns, three turns, four turns, and if there are n number of turns, then this equation can be written as for n turns. We can write here for n turns of coil. This equation will become E is equal to minus n d phi by dt. Put the value of phi from this equation. We can say equation number 1. Put the value of equation 1 in equation 2. Then we get E is equal to minus n. Then d dt of AB cos omega t. AB cos omega t. Then take a derivative of this equation. Here, this minus sign will be remains constant. N, A and B are the constant, therefore they are taken outside the derivation equation. And when we use the derivation of cos omega t, when this dt of cos omega t will equal to, this omega is constant, therefore this will be taken as this time, and dt of cos omega's derivation as the sin omega t, आणि ओमेगा कॉन्स्टंट असल्यामुळे तो आपण बाहेर घेतलेला आहे. therefore omega sin this will be minus omega cos x चं derivation minus sin x असतं. मग cos omega t चं minus sin omega t, and हा ओमेगा जो आहे तो कॉन्स्टंट आहे तो टर्म बाहेर घेतलेली आहे पण, therefore sin omega t, and here will be minus omega sin omega t. This omega, this negative sign and this negative sign will become positive, therefore this will be NAB omega sin omega t. This is the E, value of E induced in the coil, that is E is equal to NAB omega sin omega t. For, we can say here, for sin omega t, the value of sin omega t omega, that is, or sin theta also we can say, for sin theta, for setup, when the coil completes, or when we can say the coil is starting for rotation, it completes a 90 degree of angle, that is from this position to at this position, then we can say the sin omega t is equal to plus or minus 1. Plus or minus 1. Therefore, this equation can be written as E is equal to NAB omega, because here in this case sin omega t is equal to plus or minus 1. Therefore, when theta is equal to 90 degree or theta is equal to 270 degree. When theta is equal to 90 degree, then the sin omega t is equal to plus 1, and when theta is equal to 270 degree, then sin omega t is equal to minus 1. Therefore, E is equal to NAB, and this E is equal to E maximum, that is E naught, is equal to NAB omega. Now we can say this equation is here we can write plus or minus also. E is equal to plus or minus E naught, that is maximum EMF will be used in the coil, and therefore NAB omega. We can put the value of E or E maximum, that is E will be equal to, here E is equal to E naught is equal to NAB omega. Therefore, put this value in this equation. This is the equation 3. Therefore, this E will be equal to E naught. This NAB omega will be equal to E naught, and therefore this will be equal to sin omega t. E is equal to E naught sin omega t, where E naught is the maximum EMF induced in the coil, and again this equation can be written as E is equal to E naught sin 2 pi f t, where we have used omega is equal to 2 pi f, where f is the frequency of rotation of this coil. F is the frequency of rotation of this coil. Now, by using this equation, we can draw alternating current diagram of or graphical representation of EMF, that is for alternating current. Or by using this generator, we can produce AC current and DC current. AC current means alternating current and DC current means direct current. Then alternating current, why we say this alternating current? Because every half cycle the direction of current changes. Every half cycle the direction of current changes, and therefore we say the alternating current. When we use a battery or cell to any electrical circuit, then that current is direct current, because when we use the battery or cell, the direction of current remains unchanged. The direction of current remains unchanged at every position, or after some time. If we take the direction of current, then direction of current will be same in the closed circuit. But when we use the AC generator, the direction of current at each half cycle changes. When this coil rotates from this position to this position, the direction of current changes, and therefore this generator is called as the AC generator. Alternating current, AC means alternating current, because the direction of current changes alternately every half cycle, and therefore for this we can draw the initially, suppose a coil is at a particular position and this is the direction of current. Here the time or angle we can take here, the time. This will be the alternating current or graphical representation of alternating current. We can say the figure C, that is current.
36.
Here in first cycle the current will be the positive and therefore we get the positive cycle. Then the position of coil changes, the current becomes a negative and this is the maximum negative current, that is we can say that this is the minus E naught and this will be the plus E naught. And as we use, we can changes in this position of coil to get a continuously direct current. Then we will get as this type of pulses. This is the direction of current. This is the direct current or DC. This is the graphical representation of direct current. Also we can draw here as this type. Graphical representation of direct current. That is direct current is at every position. This is maximum to minimum or up to 0, and every cycle, half cycle, the current direction of current remains unchanged. That is always in the positive direction. We can do here some changes. That is each and every time the direction of current will be remains unchanged. Now we will discuss about the back EMF which is generated in the motor. This generator, AC generator or DC generator, is depends upon the principle of motor. This depends upon the principle of motor. We know that the EMF can be generated in a circuit by different ways. The battery by using the chemical force, it gives the EMF. Then in thermocouple, it is temperature gradient which is responsible for the producing the EMF in the circuit. Then in Van de Graaff generator, the electrons are loaded literally into a round bed and swept along to create potential difference. We have seen that the physical construction of DC generator and the motor is practically same. If DC generator is connected to battery, it will run as a motor. When this DC generator is connected to a battery, it will run as a motor. If a motor is turned by an external means, it will behave as a generator. When the motor is turned by the external supply, that is by generator. It will work as a generator. When motor is running, the generator action cannot be turned off. Therefore, when the motor is running, the EMF induces in the coil of motor. That is, EMF induces in the coil of motor. Suppose when this motor is connected, suppose this is a motor which is connected by the external supply, and this is the direction of current in the motor, and we are going to discuss about the back EMF. And due to when the current flows through this motor, then EMF induces in the motor, and the direction of EMF is opposite to the direction of this current, or due to the EMF induced in the coil, the current induces in the coil. We have already discussed about the AC generator. Therefore, when the motor is connected to the external supply, this motor acts as a generator, and therefore this external supply provides the current to motor, and this motor acts as a generator, and therefore the back EMF induces in the coil and current produces in this coil of motor, and the direction of EMF is direction of EMF and current is opposite to this direction of current, and therefore this produced EMF which opposes this current is called as the back EMF. This is called as the back EMF which is produced in the motor, and that is opposite to the external provided EMF and the external current. And this induced EMF is unavoidable due to the generator action in the motor, and this unavoidable EMF generated in the motor or produced in the motor is called as the back EMF. पण यालाच back EMF म्हणतो. ज्यावेळेस आपण एक्सटर्नल सप्लाय देतो मोटरला, त्यावेळेस या मोटरमध्ये this motor acts as a generator, and therefore the EMF induced in the coil, EMF या coil मध्ये induce होतो आणि current या ठिकाणी produce होतो, and the direction of induced EMF is opposite to the EMF of this battery, and the direction of current induced in the motor is opposite to the direction of current which is supplied by this battery, and therefore this EMF induced in the motor is unavoidable, and this EMF is called as the back EMF. आणि ह्या back EMF मुळे काय होतं, सुरुवातीला ज्यावेळेस मोटर स्टार्ट होते, when a motor is just starting up, the armature is not turning, and hence it is not produces any back EMF. सुरुवातीला मोटर या ठिकाणी बॅक EMF प्रोड्यूस करत नाही, त्याच्यामुळे मॅक्सिमम करंट आपल्याला सर्किटमध्ये दिसून येतो. पण ज्यावेळेस मोटर मूव्ह व्हायला सुरू होते किंवा या ठिकाणी when the motor starts speeding up, ज्यावेळेस मोटर स्पीड अप होते त्यावेळेस याच्यामध्ये मॅक्सिमम EMF इंड्यूस व्हायला सुरुवात होते, आणि then the total current in the circuit decreases as compared to the starting current. सुरुवातीच्या करंट पेक्षा ज्यावेळेस मोटरनं स्पीड घेते त्यावेळेसचा करंट सर्किट मधला कसा राहतो, कमी राहतो, and this is due to the back EMF. Today we have discussed about the AC generator. AC generator can be also converted into DC generator by changing some physical appearance. Then also we have discussed about the EMF. Okay, thank you.